Hi, Lane. Good to see you. And I'm a little bit early, so we'll get rolling here. Heath, glad to see you as well. Welcome. And I know we'll have some other folks who will be joining us. So I'm going to go ahead and start us a few minutes early, and they can go ahead and catch up. But thank you for glad to see you here. I hope you're having a good day. Now, today we're still here in Module 3. And we talked about PAR Inc. on Monday, and all that I'm asking everybody to do for this assignment right here, and let me get the annotator open so I can make sure I'm clear. All I want everybody to do is to go into the Anderson student files and go into the chapter 3, it's in that zip file, and get PAR mod. Run the optimizer and generate a sensitivity report and an answer report and then upload it. That's all everybody has to do. And the text, in the case, we spent some time talking about sensitivity analysis, and that passage there talks about how to use those reports. The main thing being we look at the changes in the variables, and we look at those allowable increases and decreases, which gives us basically a range upon which we can adjust, if we want to, those inputs. And then we also talked about the dual value, which is also known as the shadow price. And basically it's just nothing more than a measure of utility. So if I make a change in this particular constraint, or a change, if I make a change in a particular constraint, how will it affect that will affect the right-hand side? How will it then add to the objective function, maximizing profit or minimizing costs, that type of thing. So it's there. And so today we're going to take a look at Hewlett. Now, let me go ahead and erase this and close this off. And I see a fourth person's joined us. Glad to see. I'm going to mispronounce your name, Matthias. I apologize. I'm not pronouncing your name properly. I'm so sorry. I'm going to have to grab you in class. Luke, glad to see you here as well. And now we're going to look at the Hewlett. Now, the Hewlett is over in pages 166 to 169 of the text, or it's also Appendix 4.1. And we'll go in here. And I'm slowly but surely learning to add bookmarks. So we'll hit the bookmark, and there it is. And what we're going to see is that that we can use optimization as a means to deal with a variety of business problems, and to develop a mathematical model of possible outcomes, or to look for what we think would be the optimal or best outcome that we have. So you'll want to have your textbook open as we're going to take a look at this. Now, also, you'll need to go over to the Files section, and you'll see the Anderson Text Student Excel files, and you'll want to download that. Now, as I'm always say, I work in Chrome, so I go ahead and show it in the folder. I try to. There we go. And you can see, of course, I've worked with them many, many times, so I'm going to throw it on my desktop. And I'm going to open it up. And I think it's in chapter 3 is PAR, are the files. That's the PAR mod. So I need to be in chapter 4. My apologies. And so I'll get that file from chapter 4. And that's the Hewlett file. And we'll talk about that problem. Okay, here's Hewlett. And I'm going to copy it and paste it on my desktop. So I'll have it there. Okay, where did Mr. Hewlett go? Having these weird things are happening with these where they won't paste out for me. All right, let me try this again. I don't know if this is just because it's a temporary file, what the story is. All right, here we go. And I'm going to put that up. I'm just going to work in here with it for now. And then go ahead and try to save it to my desktop. So I'll enable the editing. And then we'll talk about this. Now, while I'm messing with this thing, and let me throw this over here on my desktop. And we'll call it a copy of Hewlett. There we go. Now, we're going to use the solver in this, but let's talk about the case for just a minute. And I want to start with the point that the authors make here about using this, building a model, and this is for a financial planning problem. We're going to see that we can use optimization for just about any type of business problem, and we can use the solver to accomplish that optimization. So we've got this company called Hewlett, and basically they are a financial planning firm. And you'll see here, this is from the web file, and this is also the Excel file. You'll notice that they have a set of parameters they're working with, and they start with here is their first set of assumptions. They have 8 years. They've got 3 different bonds, and you can see the bond prices there, and then the rate on those bonds, and then the years to maturity. And they've got an annual savings multiple that's built in. And then, of course, you could see the cash requirements for each year, which are there to pay out on the bond and then eventually to retire them. But we have 8 years of cash outflows. Okay? And so we have this financial model, and we have the minimum funds needed to handle the net cash flow, the cash requirement. And I'll pop this off for just a minute. You can see as we go down here, and it's a classic timeline that you'd see in a capital budgeting problem. Okay? And you can see to year 8, the cash in, the cash flow out, the net cash flow, and the cash required to pay out the dividends. And of course, you see as they get into year 8, they have cash in, but nothing that they're paying out. They have the cash in, and they have the 240. So the last 4 years, they have the money to pay the dividends, so they've settled up with these folks, and they've not had to take in any additional cash to do that. So they're trying to optimize and say, okay, what's the minimum amount? So it's a minimization problem. And the authors here are going to walk you through the decision cells. And those are cells A17 to L17. We'll go right back for a minute. Okay. And there they are, A17 through L17. So those are the decision variables. Then the objective function, that's in A17. the minimum funds needed to accomplish these objectives. And then the left-hand side of the equation, and they've got, those are cells G21, E21. And then we'll go back over here for a moment, and you can see those left-hand side. Okay. This will be the LHS. This will be the RHS, the right-hand side. Okay. Now, and the authors will walk us through the process of putting those data in, and of course the right-hand side, and then they give us the Excel solution. Now we've got the worksheet, which is, as I've said before, those worksheets I've loaded for you are solution files, okay? So you have those. Now what I'm asking you to do is to manipulate them a little bit and then run the optimizer and see what you get. That's really about all that's going on. So we'll click over here. Okay. And here's Hewlett. And you should have downloaded the Hewlett file. And basically what I'm asking you to do is just to simply change use the solver to compute the cash flows and the minimum funds needed if the price of all three bonds goes up or if the price of all three bonds go down. And I've just said, let's just do it an easy. You could have combinations of two of them that go down, one goes up. And you could change that around per bond. You could build yourself a small little matrix if you wanted to and look at those outcomes. And you've got three bonds there. Okay. And you've got bond number one. Let me put in a text box here so I can do it a lot better. Yeah, we'll just skip this for just a minute. No, we'll do this. We've got bond. It's probably going to be easier for me to do this. We've got the bond. All right. We got bond 1, bond 2, and bond 3. All right. And let me pop this out just a little bit more. And then we've got the changes or the delta in each of those. Those for the change, which will be it increases or it decreases. And so you can see for bond 1, we can have a number of scenarios where bond 1 goes up, goes down. Same thing for bond 2, bond 3, and we can build a matrix if we wanted to of the possible outcomes that we might anticipate. Here we have an assumption that all three of them will change correspondingly. Okay? And that's just not going to be always the case. But I just made it easy for you. So we can go back in here now, right? And I'll grab this. I'll open up Hewlett. And here we are. And let me get my handy dandy eraser out here. All righty. Now, again, here's the structure. And all you'll need to really do will be to come in and if I were you, I'd take the verbiage from the problem. I'm going to copy that, and then I'll come back down here and I'm going to insert a text box so I remember what I've been asked to do. And we'll find ye old text box over here. Insert. And, I want the insert function here. There we go. And there's my friend the text box. There it is. And you could size this up for your own benefit. I'm going to make that I guess a 14 font will work just as well. Okay. Stretch this out so we can see everything. So I'm going to ask you to use the solver to look at two scenarios, one in which all three bonds increase and one in which all three bonds decrease. And then I want you to generate an answer report and a sensitivity report. I don't have that on here, but you ought to start to get used to doing it. Now, I want to show you something that came preloaded. Again, the files that I'm having you use are solution files, okay? And then I'm saying, okay, and then when I give you this little bit of instruction, we're tweaking it. So I think pretty clear at this stage of the game. Now here's a sensitivity report. Okay, and we can see these final values, okay, and any reduced cost, and we see the objective coefficient, and then we see allowable increases and decreases. Then we get the shadow price, which is the same thing as the dual value. And this tells us for each change what we get in terms of additional value in the objective function. And you could look here and you could see, notice we've got allowable increase and allowable decrease. Those are the constraints to the right-hand side, of course. And then how much we can increase each of those years, and then the allowable decrease. And you'll notice that 1728, we could decrease it by that much, and that's the allowable decrease. So we could take some of these years and decrease them out. So you could say theoretically we have slack resource, but the truth is, we really don't, because the money's got to be there. It's a little bit different than if we were dealing with time, as we've dealt with in a couple of these manufacturing problems. That's really about all that you have to do. Now, again, let's go back to the solution, and we'll click on data and we'll click on solver. And there's the objective function. And we're going to change the variables A17 to B17, pardon me, A17 to L17, and that's those figures there, okay? And then we have the constraints that everything on the right-hand side has to match with everything on the left-hand side. They have to be equivalent. So then we know the minimum funds that we need to start with, and then our payouts. So our cash flow in and out till we work down and everybody's paid. As we go through the next few weeks, we're going to see that we can use solver in a variety of situations to build a model of possible outcomes. Now, one of the reasons I added this as an exercise, of course, is to say, okay, what does it look like if we look at if all three bonds increase in price? What if they decrease? And then, of course, you could work through the matrix, if you will, or permutations of this thing in terms of, well, one goes down, but 2 and 3 go up. 2 goes down, but 1 and 3 go up. 3 goes down, but 1 and 2 go up. You could just work through the permutations. Doing that, then, you have a reasonable understanding of what you might be able to do. Now, this is a little bit different, though, for the simple reason, as I said, we're dealing with money and a bond, which is a legal instrument. So if we issue the bond and we say we're going to pay a certain amount of interest, we've got to do that, okay? That's just the way it works. And, of course, the price of the bond, its value, external to this discussion, but just so that you understand, I get what we're doing here. Hopefully you will too. The price of the bond, external to this discussion, is going to be driven by what? Its relative interest, its rate of return relative to other instruments of the same or similar risk. Its market value. And of course, if it's risky, then if it's perceived more risky than other similar, if it's perceived as being a higher risk, investors will want a higher level of interest. And it's just to back the old thing of, the risk reward. The higher the risk, the greater the reward. So we're using it here to find out. We're using it for minimization, and these parameters are not exactly, this is not the same thing as time, okay? But we can use the tool. Now, the text box is going to walk you, is going to walk you through the process. And of course, they'll walk you through setting everything up, but that's done for you. And we're assuming, and we're still operating in a simplex LP environment. We assume risk reward, the higher the risk with a bond, the higher the reward, i.e. the interest paid, okay? And then they ask you to select the sensitivity reports. So this has already been done. I'm just asking you to tweak the price of the bonds. Okay, and I walk you through the sensitivity report. We saw that. And you want it, again, to review some of the verbiage as we talk about. The key thing here is this: the allowable increase and allowable decreases. And then you could come down to the constraints, and you can see the shadow price. And notice how these mirror each other. The year 2 in terms of its shadow price and what we have for an allowable decrease. So again, this helps you some, but if you've sold the bonds and if you've sold the bonds and you've told the investors, here's the rate of return that you're going to get, you have to pay that. So you say, okay, well, Dr. Ryan, if that's the case, what's this business about changing the price of them? Well, the price of a bond fluctuates according to what? Its rate of return relative to other similar instruments, financial instruments that have a similar rate of return. if you're offering 6% interest and somebody can get on your bond, and someone can go back and they've issued a bond where they pay 10% interest, investors are going to go where they can get 10 versus 6. Now, this is just basic finance 101, and you would understand that, but you can see how these folks are trying to plan for changes in the, you might want to plan for changes in the price of the bond, okay? And some of this will determine, and I know we don't have any finance majors, I don't believe we have any finance minors or emphasis folks, but that, and it would depend on also, is the bond, is it callable? Is there a provision where I can call it at year 3 or 4 and say, okay, I want my money back? Or is it linked to a derivative of some kind? Who knows? But the authors have just showed us a simple cash flow in, cash flow out model to see how we can say, okay, what are the minimum funds we need in order to accomplish the parameters, basically what we've used to sell these bonds to investors. Okay? So there's nothing all that terrible about it. And also to take a look, again, to become familiar with and comfortable with looking at the sensitivity report. And again, to emphasize to you how versatile a tool this is. I've got a nice mathematical model that I built it out, and I can look at, well, what happens if the prices increase or the prices decrease. And then the price of the bond is going to fluctuate on the basis of the rate of return that investors get from your bond versus what's out in the market. Okay? And that's something over which you have no control. And not only your bond versus other bonds, but your bond as a financial instrument versus, say, equities. How's it going to compete versus equities? Okay? Now, just to help you understand a little bit better, if you take my investment profile at this stage of my life, I have everything put into guaranteed income. Why? I'm 4 or 5 years out from retirement. On the other hand, if I were a young person, I'd be deep into equity because I'm trying to build the value of my portfolio. And equity is where the growth's going to come. So that's pretty much all there is to Hewlett. Nothing terribly complicated about it at all, but just recognizing of what you can do with Solver. Now, if some of you should say, well, I think I'm going to try it by using some of these different permutations. Let me write them out here for you. We'll just so you'll understand what I'm talking about. And one would be the price, and we'll keep all of these changes at an increment of 2.5%. The price of 1 goes up, others constant. Okay, that would be a permutation. That would be a third one. There'd be a fourth permutation, and you can get it. And I'll just copy this. You don't have to do this, but you might find it fun just to see what it looks like. The price of 2 goes up, and the others are constant. I'll move myself up here for a second. My grappling hook here. And then we have, so we have 2, we have a fifth scenario. The price of 3 goes up, and the others remain constant. Okay. And then you could say, okay, you could continue to work out all the permutations How will this look? Okay. Now, the authors at the start of all of this, and then when you get in the first chapter of the text, talk about controllable versus uncontrollable events or conditions. Okay. And so in this, when we're looking at the price of a bond, the interest rate that I pay on a bond is a given. I issue a bond and I tell the investors, here's the cash flow, and just a traditional bond where there's an annual payout. There could be a quarterly payout, there could be a monthly payout, but you have an interest rate that you meet, which then implies a dollar amount given that price of the price of the bond. That's controllable. What's uncontrollable are market conditions, other folks' offerings, and market conditions vis-a-vis, say, a bond versus an equity, say, versus real estate. Okay? So we don't do any NPV in this problem, and I understand that, you know, when you're so many years out, you've got to get the cash flow, which is perfectly correct. You have to use the net present value of them. I understand it, but we're just simplifying this problem and say, hey, I can use the optimizer to generate scenarios, run them, and see what they look like. So I have a sense of really good conditions and really bad condition. And the really good condition here is going to be if the prices of these bonds go up, okay, that's good for you, okay? If the prices, because the market's driving, there's a demand. If the prices of all three go down, there's little or no demand. That's the other end of the spectrum. And then in between, you have some of these additional permutations that I drew out. Well, let me stop for just a moment, and we'll go back up here for and see, is there anybody that has a question about what we've done? And I'll pop in and see all we've got here. Okay. Hannah's here. Heath, glad to see you. Anybody else that I might have missed? Luke, Matt, glad to see you here. Anybody have a question I could help you with? Okay, that being the case, I assume, based on your non-response, I'm going to forge ahead here for just a minute, and I want to talk about what we'll be doing a little bit of next week. And again, just so you know, all I want you to do for this assignment is to go in and get the file par mod out of the Chapter 3 student files, open it up, take a look at the sensitivity report that's there, and then upload it. That's all you've got to do. Here, I've asked you to input some data. Yeah, okay? It's just a way to introduce you to the solver. And, pardon me, a way to introduce you to the sensitivity report. And we want to pay attention to them so we can see allowable and decreases and increases. We can look at the dual value, i.e. the shadow price, so that we have a sense of where we are in terms of the continuum of outcomes. We're using the tool not to find the best one. And I want to show, and just to reinforce that point, okay, I'm going to click on the solver. Notice that we have three choices: maximization, minimization, or the value of. The value of is a target objective function. I must have this value. What do I have to do to get there? Here I'm minimizing, or here I'm maximizing. So the solver tells us that. And then, of course, we have the changing variables cells. What variables are we changing? And then we have the constraints. But the whole point of using the optimizer, and the reason I have you tweak these, is because since it's a mathematical model, and I can easily manipulate the variables, I can change those figures. I can say, well, what if this could happen or that can happen? I can engage in scenario analysis using this to look at one of three. What's the best outcome? What would be the best outcome? What could be the worst outcome? What's maybe most likely, or what's in between the two of those extremes? And as decision makers, that's gold, because then we have a sense of how things might go. It's naive to assume that you're going to get exactly what you think. So you just don't know. Well, if you don't have any questions, let me pop us back over here for a moment to next week, and we'll take a look at it. So back down to the modules area. And for next week, you'll see we've got 4 different cases: relax, welty, Janders, and leisure. Next week, we will take a tour of all of the types of problems I can use Solver to help me understand and to plan for the possible outcomes. Okay? And next week I have some nice resources there for you, some things I've curated. One is the person who invented the electronic spreadsheet. I have just a short history of operations research. Management science comes from that. Operations research mostly done during the Second World War by the British, the British put their brains, during the Second World War, the United States and Great Britain decided to do the thought work that needed to be done. As such, Great Britain would handle operations research, which dealt with logistics, potential losses of life, casualties, the development of radar and sonar technologies. And so the scientists in Britain who stayed behind when Hitler was about 90 miles across the channel or whatever it is, the rest of them went to the United States to prepare to build the atomic bomb because they knew the Germans were working on this. So when you understand that this is management sciences, it was birthed in that type of environment, you could see that struggling with the uncertainties of casualties, for example, in an engagement, or trying to figure out how to get stuff halfway across the world were pretty challenging problems. And so I wanted you to see the history of management science so you could understand it's based on the scientific method, and that's really covered in Chapter 1, but it goes beyond the scientific method when we say there's a difference between problem solving, okay, and decision making. And then that whole idea of trying to look at potential outcomes, that mindset which says, I'm optimizing, I'm doing the best I can with what I have. Now you say, well, any idiot would do that. No, you really have to work at this, and you really have to train your brain to say, I'm always thinking about making the best of what I have. If it won't work, then I need more people or more money or more resources, or if I can't reach an objective function, and we had one of those problems this week, then it's my responsibility to go back to my boss or to say to my employees, if I'm running the place or if I have reports and I'm running a part of a company, to say, I'm not getting a solution here. So what do we need to prepare for in terms of not meeting what we not being able to accomplish exactly what we want to accomplish given the resources we have? This imposes a discipline on the conversations between management at all levels that forces them to be less political and less suboptimal and more optimal and more rational in their decision making. Okay? Now, it's rarely going to work out like that, but at least you have a tool that you know that you can do. And if you're talking about making decisions that might impact the lives of 20,000 employees that work at a plant in a town, you really got a lot on your shoulders. Because if you mess up, you might close that place down and you kill a community. That's why I've said, business students, you have tremendous power, the power to do a lot of good and a lot of bad. Well, folks, I think I've covered what I needed to. And we've talked some about these resources. Don't forget also, I have some those resources we'll have next week. Leisure Airlines is a fascinating case. And low-cost airlines, another one of these. We're dealing with an airline. Leisure is an airline handling a routing problem, a logistical problem it's trying to accomplish. Okay? Well, if you don't have any additional, if you have any questions, I'm happy to try to answer them. Does anybody have a question? If you want, you can hit the chat thing and it'll pop up a little chat question and I can try to answer it for you. You can chat with me, or you can signal me and I can let you ask it. I can take you off of mute and let you ask questions so everybody can hear. Anybody? Okay. Well, folks, I'm going to shut it off then. Thank you so much for being here. I appreciate it. I think we started 5 or 10 minutes early, so we're not too far off of 50 minutes anyway. And I hope you'll start to see as you work through next week's cases, you work through Hewlett, and if you decide to work ahead, that's fine. You'll see this is an incredibly beautiful tool that you and I have to help in making decisions. Thank you so much, and I will see everybody Monday.